So today's theme is leveraging technology for better tomorrow. And I'm so happy to share that we have an apt speaker to speak about this also. So with a IEEE Day greetings, may I request Professor Kasim to give a brief on what this IEEE Day celebration is all about. Over to you, Kasim, sir.
Thank you, Dr. Mini. And good evening to one and all. And as all we know, IEEE is the merger of two international organizations, the American Institute of Electrical Engineers, formed in 1884. And the signers of American Institute of Electrical Engineers was on 11 April 1884. That is the OU formed on this date. And the first conference of American Institute of Electrical Engineers was on 7 to 8 October 1884. And this is as part of the landmark International Electrical Exhibition organized by the Franklin Institute and held in Philadelphia, Pennsylvania in 1884. The American Institute of Electrical Engineers, a predecessor of IEEE, held its first conference on 7 to 8 October 1884. This meeting was the first formal technical conference on electrical engineering held in the United States. In memory of the first meeting of its members at this conference, IEEE began to celebrate IEEE Day all over the world with effect from 2010 on the first Tuesday of October, and that was on 5th October 2010. And this is the 13th IEEE Day celebrations all over the world. And so this is the background of IEEE Day celebrations. Thank you. Over to Bijoy for introducing the speaker.
I just want to check if Abhilash has joined. Mini ma'am. I don't see him in the list.
He was there. Now I don't see him. He was here.
Yeah.
As Abhi. I think he lost the connection. 1 minute, I'll check.
Yeah, I think I'll introduce once he joins. Yeah.
Yeah, I'll just check once again. He was there. He is rejoining, Bijoy. He is having some technical snag at his end.
Okay.
So just a minute. He said he's rejoining.
Kasim sare cake oda.
Kasim sir കേട്ടില്ലാന്ന് തോന്നുന്നു.
സാറ് കേൾക്കാത്ത പോലെ ഇരിക്കുകയാണെന്ന് തോന്നുന്നു.
എന്താണ്?
Okay.
Am I audible?
Yes, you are.
Yes,
Just a minute. Okay. I think Bijoy will be introducing you. Over to you, Bijoy.
Yeah. Hi, Dr. Abhilash. It is my pleasure to introduce you to the IEEE audience. Dr. Abhilash is the director of ACCAR, as we call it in QSAT, or Advanced Center for Atmospheric Radar Research at QSAT, and an assistant professor at Department of Atmospheric Sciences. He was previously visiting scientist at University of Miami, USA, and National Center for Atmospheric Research, USA. After his PhD at CUSAT, he has worked in Indian Institute of Tropical Meteorology as a scientist as well. He has been awarded the Stark Scientist Medal for his research on prediction of convective storms, and he has received the Indian Meteorological Society Award on Weather and Climate Services. He won the Best Young Faculty Research Award at CUSAT in 2019. He's a principal investigator of a project worth 11.7 crores here, and serves in the several panels on meteorology as an expert member. Today, a very contemporary topic as we face, climate changes, and as IEEE being a technology organization, he'll talk to us about technology innovations to meet climate change. Welcome, Dr. Abhilash.
Thank you, Dr. Bijoy. Actually, sorry for the trouble, because later I joined, but I was not able to hear the voice. So I think now it is okay. Let me thank the IEEE Cochin chapter for giving me this opportunity to talk about the recent challenges in climate related crisis and challenges, and maybe the opportunities related to climate change. Let me share my screen. Is it visible?
Yes, it is.
Yes, yes.
The slides are moving, right?
Yeah,
Slides.
you can move. Yeah, it is listed there.
Yeah, it is moving, right? Can you able to see?
It is not in the presentation mode.
Okay, okay,
Yeah.
okay. Okay. Meeting. Is it okay now?
Yes.
Yes, yes.
Yeah, yeah. Okay. Okay, at the outset, I thank the organizers. And today I will be talking about some of the technological innovations to meet the climate crisis and challenges. So we all know that the present humanity, not the humanity, the entire Earth is suffering from the adverse effect of climate change. So it is climate change assessment is really a cyclic process where the first step is to detect the changes. So that means we have to detect what are the changes going in the entire spectrum of the earth in terms of heat waves, the melting of glaciers, storm surge, extreme temperature, and extreme weather events. So after the detection, we have to go for attribution. So how it has happened. So it's a cycle. So after detection, then attribution. Then we have to analyze what are the impacts associated with it, because there are a lot of impacts related to climate change, disasters, ecosystem degradation, resource depletion, mass extinction crisis. All these are the common impacts related to climate change. So immediately we have to go for adaptation strategies, and then we have to devise long-term mitigation strategies. And then again we have to, because why it is a cyclic process is that because every year we get new information regarding climate change and the new information regarding the impact assessments. So we have to revise our strategies to cope up with the new pattern of changes and new information regarding our basic understanding about the changes. So it is a cyclic process. That is why IPCC, Intergovernmental Panel on Climate Change, they come up with new state of the art and the new status of the climate of the earth, and in a over a period of like 5 to 6 years. A recent assessment cycle came recently last year, September. It is IPCC Assessment Report 6. So based on that assessment, cyclic assessment reports, we have to devise our, we have to change, make changes in our mitigation strategies and adaptation strategies. So here, all spectrums like addressing the climate change, starting from the detection onwards, detection, attribution, impact assessment, adaptation, mitigation, all this process involves a lot of innovation, because with the help of innovative ideas and innovative technologies only, we can make all these assessment cycles. So every step we need a new set of ideas, innovations, and strategies to mitigate these impacts. So it is like running a fever. First, we have to identify the symptoms. Symptoms are nothing but the planet temperature and carbon dioxide is increasing. Then we have to diagnose it. We have to go for diagnosis, and once we diagnose, we have to prescribe medicines for that. Then we will go for treatment. That is nothing but in this case, it is mitigation and adaptation. So a little bit of history of Earth, because starting from Earth has a history of over 4.656 billion years. But if you look at the last 500 millions of years of Earth history, Earth climate never remained in a static state. It is a dynamic system, and it keeps on changing over the years. So that means if you look at the last 500 million years, Earth climate was changing like this, oscillating, or maybe there are a lot of cyclic process like glacial, interglacial cycles over a periodicity of 1 lakh years. So, but on top of that, there are drastic changes in the climate that had happened in the past. So I am not discussing about it, because all this extinctions, because we know that most of the biodiversity, all our biological fauna and flora of the Earth diversified after 550 million years. It is very recent, because compared to 4.56 billion years of Earth history, there are the biodiversity really enhanced, or biological spectrum diversified in just 500 million years. So in that 500 million years, we have the Earth has witnessed almost like a 5 mass extinction events, and that has got a direct link to climate. And here, just because this is an interesting subject, because paleogenomics, recently the Nobel Prize for Zoology and Medicine went to Sante Pabo. He for his discoveries on the genomic studies related to extinct hominins like Homo neanderthals. So what he did was, because his study was long back, because he's considered as the father of paleogenomics. Now we know that with the modern supercomputers and all, we can derive different the genomic studies are basically nowadays done with the help of advanced supercomputing facilities. And Pabo is well known for his contribution in this paleogenomic studies, and that's why he derived the genomes of Neanderthals, and maybe our Homo sapiens also sometimes met with the Neanderthals, and he find out that 1 to 4% of our genome genetically there is 1 to 4% similarity between Homo sapiens and Homo neanderthals. So and then another species known by Denisovians. I am not discussing much about that, because technology only made this possible because the genomic studies are with the supercomputing is nowadays as a emerging subject due to various reasons, like finding out proper medicines and finding out the genomic sequencing that lead to a lot of many advancements is happening in this field. So this is how the paleoclimatological studies is being conducted. We derive the past history of the Earth based on the proxy data, which the information regarding the history of the Earth is evident in some of the fossils, and that also different type of fossils provide different opportunities at a different temporal and spatial scale to analyze our past climate. So, and coming to the recent 4 lakhs of years Earth history, we see that this is derived from ice cores samples, and the beauty is that at the same time we can derive the temperature of history of the Earth and also carbon dioxide history of the Earth. So here it is showing that the red color is temperature history. That, as I told, it is a cyclic evolution connected to the glacial interglacial cycles, and now we are at a interglacial period. So in tune with this temperature changes, we found that the carbon dioxide is also changing. The carbon dating studies and this paleoclimate studies is evident that temperature and carbon dioxide varied in coherently, because it is not evident that whether carbon dioxide is driving the Earth temperature or temperature is driving carbon dioxide concentration, but both are together varying, and it is a co-evolution. And if you look at the recent 150 years after the major the industrial revolution happened in Europe, we can find that the present concentration of carbon dioxide is shooting above 4. It is touching present day carbon dioxide concentration, which is measuring at the Hawaii Islands. It is known as Kohler curve. So it is almost like 420 parts per million by volume. So the natural threshold limit of carbon dioxide is normally 300, but on top of that we are reaching up to 420 ppm now. That happened in just 150 years. If you look at the past history, the cyclic changes had happened over a period of 75,000 to 1 lakh of years. This is connected to the Milankovitch cycles, connected to the orbital changes happening on the Earth. So that is a natural process. So this is happening. This variability between 200 and 300 in terms of carbon dioxide concentration, that 100 ppm variation is happening over a period of 1 lakh of years. So now what is happening in just 150 years, the carbon dioxide has been overshooted above 300 and it is now 420. And that means on top of the natural threshold limit of 300 ppm, on top of that we reached almost like 120 ppm on top of that. So that had happened in 120 years. That means 1 ppm per year or 1 to 2 ppm per year rate we are dumping carbon dioxide to the atmosphere. So this is the present situation that is making all these climate change issues. So that means the science is that we have, by budgeting studies, we can found that due to all our natural and anthropogenic activities, we are emitting almost like 9 gigaton carbon. It is almost equivalent to 3 into 3.6, almost 25 to 30 gigaton carbon dioxide equivalent. So out of that, our land surface, including our forest and forest plants and trees, they absorb almost like 3 gigaton carbon, and our ocean absorbs almost like 2.5 gigaton carbon, which leaves almost like 4.5 gigaton, almost like 50% of the carbon dioxide we are emitting now due to anthropogenic activities, combined anthropogenic and natural activities. Out of that, almost 50% of the carbon dioxide is being dumped every year, and that is why this hockey stick type of increase in carbon dioxide concentration along with the temperature is also increasing like this. So that is the main reason for this. This is from the budget studies. That means every year we are dumping carbon dioxide excess almost like 5 gigaton carbon to the atmosphere. So this is the problem now. So this is the main drivers for this is nothing but the global warming connected to greenhouse gas emission. And also there is a direct link to the explosive population growth. We know that the population is almost touching to 8 billion compared to the last century. It's almost like less than 2 billion to 8 billion we are reaching. And now the air pollution, water pollution problem is also increasing. And then plastic pollution is another issue. Then deforestation. All this together is making this carbon dioxide concentration to the atmosphere. So that means that we know that we have detected the changes maybe 30 years back. We were IPCC giving alarm to the humanity or the policy makers that after maybe if we are continuing emitting carbon dioxide to the atmosphere, it will end up like lot of extreme weather event all over the world, not only the north to south, east to west, pure rich, whatever spectrum of everywhere the climate change issue is feeling. And there and another is this all related to the net radiative imbalance at the top of the atmosphere that is contributed by anthropogenic and natural factors. And if you look at the anthropogenic factors, there are two contributions. One is from human activities, one is in terms of greenhouse gas emission, that is nothing but CO2, NO2, methane. They are the major contribution. So that makes positive energy imbalance in the earth. And at the same time, another anthropogenic activities that release lot of aerosol particles to the atmosphere. So that is having this, especially the sulfate aerosols, and they have some kind of scattering property. So that some of the sunlight which is coming from the sun is being scattered out to the space in the presence of the species. There are black carbon, they absorb the aerosol, but the net effect of aerosols is the negative radiative imbalance. Altogether, if you look at the positive radiative imbalance from the greenhouse gas and the negative imbalance from a contribution from the aerosols, altogether the net contribution should be on the positive source. That is almost like 1 to 1.5 watts per meter square extra energy imbalance. That is per meter square this much energy imbalance. That means the meaning, if you want to visualize, we can with this much energy imbalance, we can light up a 1 or 2 watts, 1.5 watts bulb at every square meter on the Earth's surface. That is what the meaning. So this is measured nowadays with the satellite data and all. We can measure this as, because this is the total planetary energy heat uptake to the ocean, because we know that 93% of this excess heat is being absorbed by the ocean, because heat capacity of the ocean is very large, the mass is very large, so that the most of this heat is being absorbed in the ocean. If you that means 93% of this excess heat is being absorbed by the ocean. That we can measure the excess heat absorption by the ocean can be measured with satellites. So that is a kind of indirect measure of this energy imbalance, because 93% is being absorbed by the ocean. So that way we can measure that this energy imbalance is increasing. So now it is touching almost like 1.5 watts per meter square. So in another way, with the technological advancements, we can say with confidence that nowadays with the huge computing systems, and we can make computer models based on mathematical models or prototype models based on mathematical equations governing the physical laws and all. So we can formulate exactly the climate system with the mathematical equations. That is nothing but we call it as climate models or weather models. With the climate models also, we can say with confidence that this is the climate model simulation of the average temperature of the Earth. So it is anomaly. It is with respect to a baseline period of 1850 to 1900 compared to this pre-industrial or the 19th century baseline period. The Earth temperature, this is the observed Earth temperature. The red curve is the observed Earth temperature. It is almost like touching 1.2 degrees excess compared to this baseline period. So that means Earth is warmed by 1.2 degrees Celsius compared to the pre-industrial period. And if we run our models only with the natural forcing, like external forcing from the sun, orbital changes on the earth, and volcanic effect, all this only we will run the model with the natural factors only, then that time the model end up with like a 0.2 degrees Celsius warming. And when we add the all anthropogenic activities like human induced emission to this model, then only we can replicate the observed changes. So that means this must excess, almost like 1 to 1.2 degree excess warming is produced by human activities compared with the natural factors. So that with that, this is also kind of technological advancement to say with confidence that our earth is warming because of the human or anthropogenic activities. So, and for the future projection also, we don't know because future projections are not really predictions. It is a kind of different scenarios because we don't know what is our future emission scenarios, because right now we are taking a lot of measures to reduce the carbon emission in terms of cutting down the CO2 emission by alternative energy sources and carbon capturing mechanisms. And so the future emission will be depending on the socio-economic pathways in the future. So that will determine how much carbon dioxide we are going to emit in the future. So that it is like different roads because in front of us, if we have five different paths, we can select what path we have to go, and we can reach the destination without any much hassles. That is the main aim of this computer means IPCC climate model projections. That is, it is not similar to the weather forecasting, because weather we are with a certainty we are predicting for the future, next day, 2 days or 3 days in advance, but the projections we are giving for next 100 years or 200 years. So that is based on how much is the path, what is the pathway of our socio-economic development, and how much CO2 we are going to emit, when we will achieve the net zero emission. All this together is contributing to. So that means for it is future projections are not exactly the prediction. So it will provide different pathways in front of us so that we can select which pathway is more suitable for us in a optimum way to reach to select. It is actually a way to select our destiny based on this projection. So that means if you look at it, there are different type of medium, low emission projections, medium emission projections, and high emission projections. If you look at, if you continue our business like this, this SSP 8.5 scenario tells us that by 2100, the earth temperature would be something like 4.5 degree warmer than the baseline period. So that is the meaning of this. So that means we should not go, or we should not continue our business as usual approach. So because that will end up like by 4.5 degree excess warming compared to pre-industrial period. We know that 1.2 degree warming itself is creating a lot of issues, not only to the human, the entire ecosystem. So we cannot take that path. And then a medium emission, even with a medium emission, that is but we will reduce our emission in the future. And that, even that type of medium emission scenario also, it is like 2.5 degrees Celsius warming. So that means this way, which type of pathway we can select, this type of future projections based on computer models will tells us that which pathway we have to select for the future. This is basically for mitigation purposes for the policy makers and all. So this is how the technology is advancing and helping the climate modelers or the policy makers to select our future for a sustainable future. And that is how the technology is advancing. So now coming to the climate system, the physical system of the earth, because as a earth system, it composed of lithosphere, that is solid part of the earth, and then atmosphere, the gaseous part of the earth, and then the hydrosphere, which includes both all phases of water, like because gases will go as water vapor in the atmosphere, but the liquid phase and the cryosphere, the solid phase, will come under hydrosphere. Then biosphere. Biosphere includes all type of flora and fauna, plants, animals, everything. And now thing is that a new addition to the biosphere is being added, that is known as anthrosphere. So earlier human were the part of biosphere, because we were also considered as a part of biosphere, and we were not having that much power to alter the functioning of the earth system. So now thing is that though geologically we are in the Holocene period, but it is termed as Anthropocene, because we become a geological scale forcing to change the functioning of the earth system, and we can alter the destiny of the earth system. So that is what, though there is geologically it is Holocene, it is termed as a Anthropocene in the maybe in the last 100 years. So there are different debates regarding this, whether we have to say it as a Anthropocene or Technopocene, because Anthropocene, if you term it like Anthropocene, that will give a misleading concept, because even though the world population is heading towards 8 billion, only less than 10% of this population is contributing to this problem, because in terms of emitting greenhouse gas emission, our tribals, ecosystem peoples, they were not even contributing anything to this problem issue of climate change. So there are two schools of thought, whether it has to be termed like Anthropocene or the Technopocene or the Carbonopocene. So that is another debate, because all this 8 billion people are not directly linked to this problem. That is another controversy. But on top of that, what we can say is that it is a new geological era known by Anthropocene, the period in which people have become a defining global force. The Will Stephen of IGBP named it as, it is difficult to overestimate the scale and speed of change in a single lifeline. Humanity has become a planetary scale geological force. And frankly speaking, the humans started hunting mammals from 50,000 years back. Then rise of agriculture, that has entirely changed the soil of the earth. And then by 5,000 years back, soil degradation happened. And 1700 years back, industrial revolution started in UK, and 1950 onwards, that is known as Great Acceleration period. So the Great Acceleration is nothing but there are two spectrums, like socio-economic trends and earth system trends. So socio-economic trends is connected to more or less the human factor, and the earth system trends, which is connected to the physical aspect of the earth. So here, if you look at the socio-economic trend, first is nothing but the population that increased from 2 billion to almost like 7.58 billion in just after 1950. That is why it is known as, this era is known as a Great Acceleration period, where because in connected to that, our GDP is increasing drastically after this 1950. Our foreign direct investment is increasing. The urban population, that is also maybe the projection is that almost 40% of the world population will be living in the urban cities. That too, out of that 70% will be in the urban population. Out of the urban population, 70% of the people will be living in the coastal regions. So another is the primary energy use also increases. So this all can be connected to the population increase, and then fertilizers use, large dams are built, and water use is increasing. So all this is connected to socio-economic trends. In connected to the earth system trends, the most evident factor is the carbon dioxide concentration, that also increased that drastically after 1950. So these are the and then many factors connected to nitrous oxide, methane, the marine fish capture, because the fish productivity is we term it as the fish productivity in the ocean is decreasing, but overfishing is also increasing. That is also another factor. So that means all together we are facing a lot of issues connected to climate change, and we are facing a lot of stresses related to climate change. So these are the challenges. So how we will cope up with the, and we know that more than 75% of the excess carbon dioxide on top of the threshold limit of 300, this one out of this 120 ppm excess carbon dioxide is contributed by and in that 75% of this is being contributed by the developed nations. And if you look at the spectrum in terms of flooding, for example, I'm mentioning here only flooding, that is considered as a more means frequent natural hazard. So if you look at this flooding issue, we can say that all these South Asian countries, including India, part of Australia, Indonesia, Malaysia, Vietnam, part of China, and also the Pacific Island nations like Philippines, Hong Kong, all this region is suffering a lot, including Bangladesh, Pakistan, Nepal. Pakistan recently, we know that almost 2,000 people killed in a recent flooding event. So that means in terms of absolute numbers, Bangladesh is most affected, followed by India in terms of absolute numbers. But in terms of relative population, Cambodia and Bangladesh is the first, and India comes later. So that means the extreme weather events in terms of flooding events is mostly affected to the developed underdeveloped nations or developing nations or third world countries. So this is another injustice regarding the climate change, and these are the spectrum of changes what we are witnessing in terms of climate change. So in terms of extreme weather events, also the both frequency and the intensity of this extreme weather events is going to increase in the future, as with the future risk of this, because hazard pattern is changing, vulnerability is changing. Vulnerability is nothing but it is a socio-economic factor connected to the socio-economic aspect. It includes the exposure also, and then capacity to cope also depends on these economic factors. So that means altogether the climate change is making a lot of issues. And if you come to Kerala also, the almost same things we are realizing over Kerala for the last 5-6 years. And another major thing is the species extinction rate is increasing. Almost all amphibian species, 40% of the amphibian species under the verge of extinction. So here comes another analog situations where maybe 60 million years back, we were at Paleocene, Eocene thermal maxima. Now we are at this point, almost like 1.1 degree warmer. That time, Earth was warmer by about 10 degrees, more than 10 to 12 degrees compared to the baseline period. But here now we are at 1.2. But our climate model projections are saying that in another 100 or 200 years, we are reaching to a level of 10 degree more warmer climate. So this is almost like similar to the Paleocene, Eocene thermal maxima, an analog situation where we had witnessed, Earth has witnessed a major mass extinction event. So that also is another problem connected to climate change. And here we can say that ecosystem is very much important, because yesterday was the World Ecosystem Day. So that also has to be celebrated as in line with the IEEE Day celebration. That is also very much important. We should know that we are not above the nature, because we have to primarily depend on our food for the primary producers. That is our link to the nature. And these are the spectrum of challenges we are going to face in the future. Interconnected pressure, that is nothing but water, energy, and food. So these are the three interconnected nexus on which we are going to face in the future. That is nothing but it is estimated that 30% more water we require in the future, 40% more energy, and 50% more food. by 2030. So that means so there is only one way to cope up with that. So that is why UN, United Nations, they devise new global goals. There was a Millennium Development Goals up to 2015, but that was not enough to meet all these challenges. Then they introduced a Sustainable Development Goal by 2050. So this goal is built on three basic principles, like to end the poverty and protect the planet and ensure that people enjoy peace and prosperity. These are the three fundamental basic principles on which all these 17 sustainable development goals are built. Because earlier the Millennium Development Goals there were less mentioning about the nature part of it because the development was means the nature part of the planet, earth system part of that was not that much discussed much in Millennium Development Goals. Then it is realized by the UN and included in and this all these 17 development goals, all this 17 development goals are directly or indirectly connected to climate, because no poverty means we have to produce more food. Poverty and hunger means we have to produce more food. Food production depends on water and soil. So soil and water depends on climate. All this, even clean water, sanitation, that also got a climate link. Affordable and clean energy is very much important. And then the new addition in terms of planet is these three parts: climate action, life below water, life on the land. All this, because if we preserve this, then only we can satisfy all this or achieve all these 17 goals. That is why UN itself realize the importance of the environment or the planet in terms of achieving the 17 sustainable development goals. So we have to know the value of the nature and the value, because if you weigh it, it is very difficult to measure the value of the nature, because often assume that the environmental damage is an inevitable price of progress. It should not be like that. However, the value of ecosystem services provided in nature is at a major cost. Most of our development activities neglect these issues, the value of the ecosystem service. Actually, we cannot measure the service the ecosystem is providing to us. So that is very difficult. We cannot value it. So that is also we should keep in mind, so that for the sustainable economy, we have to redefine our development. If the world is to achieve the sustainable development goal to raise the living standards while avoiding the worst impact of climate change, resource depletion, and ecosystem degradation, then economic change is very much changes in the usual practice of economy is also very much essential. The core value that underpin sustainable development: interdependence, empathy, equity, personal responsibility, and integral justice. So on these themes only we can make a sustainable future planet, and our innovation should address that. Rather than going for a linear economy, we have to go for circular economy without making any waste from the product, because earlier the waste is along with the final product, waste was also produced a large the circular economy try to recycle or the reuse the waste, and then there is another sector evolving as a recycling sector, so that it will reduce the impact or the on the earth. So every time the innovation come up to save humanity, so for shaping the future. So since the start of the first industrial revolution, successive waves of innovation have driven economic development and led to improving the life standard of billion people. A new wave of innovation is breaking and could be vital in enabling development that respect the planet. This is also very much important. That is what it starts from water power, steam power, electrification, space age in 1970s, and digital world in 20K. And then now world is moving towards sustainable innovation. So that means only this type of technological solutions will save our future, in which the basic root cause of this climate change is nothing but the carbon emission. So we have to shift to low carbon development plans and low carbon development in different sectors. The intervention for low carbon technology has to be the future technology. And here there are a lot of renewable energy spectrum is also available in front of us in terms of solar, thermal, even wave energy or wind energy. All this renewable source of energy is there, so that the solar, the thermal energy, solar, photovoltaic, efficient solar cell, like two sides of the solar cell panel is being coming nowadays, and energy from urban and industrial waste, wind, biomass, all this, and also paradigm shift from the shift to hydrogen based fuel source. So that this is the future way for innovation. And then in the transport sector also, hybrid electric vehicles, battery efficient batteries, all this has to be come in transport sector. And then infrastructure in terms of green construction materials. So we have to devise. I'm not going to going one by one there. These are the opportunities available in front of us to meet the climate challenges. And then agriculture, there should be a paradigm shift is required in terms of productivity connected to the agriculture, because agriculture is, or horticulture, or other type of aquaculture, whatever it is, there are lot of innovation has to be happened in terms of agriculture, other fields, and industries also, cleaner fuel technologies, energy efficient technologies, and productivity improving technologies, optimum use of energy technologies. All this at the same time we have to conserve the biodiversity also. There are few examples like net zero emission, that is because world is moving towards net zero emission by 2050. That is the aim of this recent Glasgow summit, followed by the IPCC AR6 report, because world is agreed to meet the net zero emission by 2050, and India committed for 2017, but Kerala committed for 2035. But net zero emission is the need of the hour. So for that we require a lot of mechanism to reduce our emission. At the same time we have to capture the excess carbon dioxide to the earth through artificial or innovative ways. One way is by improving the photosynthesis capability in the land and ocean. That also there are different ways by we can improve that, but there are a lot of debates on that, where we alter the natural functioning of the ecosystem. One changes happening in one side can have adverse impact. So there are different issues connected to, but this is another carbon capturing story from net zero Teesside project that NCDT, they aim to capture, produce in the industrial process and power plants, and transport these emission by pipeline to the offshore storage site, because they are going to store this excess carbon dioxide captured and stored in the near the shores. And then feeding cows with the seaweed, because the main contributor of methane emission is cattle, because methane is considered as a 20 times more global warming potential than carbon dioxide, because there are a lot of methane deposit on the seabed, and also in the as a permafrost and all. So they are nowadays exposed due to melting of the glaciers and all. And so if methane is also coming out from the surface, so that is going to have much more impact than carbon dioxide. So we have to cut down the emission of methane. So the largest producers methane production is coming from cattle. So that means there are changes in the feeding, because if you use, there are means scientists have used the seaweeds for feeding the cows, and they found that that can reduce the emission of methane from the cattle sector. So then the climate repair projects are there, because if you can refreeze the polar region, so that will increase the albedo, because the energy coming to the Earth's surface, the net energy available to heating up the Earth's surface, depending on the how much is the reflected energy back to the space. So that means albedo, that is the albedo reflectance of the Earth. So that depends on, mostly depends on the surface coverage. If it is covered with ice, the reflectance will be more. So that means there is a feedback loop is happening, because the glaciers, when the glaciers are melting, naturally albedo is also reducing, because more land surface will be exposed to the sunlight, so there are more solar light will be, solar energy will be absorbed. So that means the melting of ice is one problem. So that will reduce the albedo. So that means more energy will be available to heat up the Earth. So that means, so if we repair that melting problem there itself by refreezing the polar region, there are different ways are suggesting. So it is not attempted anywhere, but there's another opportunity. So because the Center for Climate Repair at the University of Cambridge is investigating a number of ideas which would repair the damage being done by the human pollution. And among their ideas are refreezing the ports by brightening the clouds above them. Because if there is a cirrus cloud, because cirrus clouds are composed of mostly ice crystals, they have more reflectance power. So if you produce more cirrus cloud over the two poles, like above Arctic or Antarctic, so that will reflect more sunlight, so that the surface will be cooled down. So that is one way. And there are many engineering mechanism is being proposed, like reflecting surfaces at the top of the atmosphere. They are not, but it is not much attempted anywhere. But these are some of the proposed solution to repair the climate. And then greater use of data center. We know that this is also directly, this is a business model, the data center or the cloud computing and all, but it really helping the climate issue, also reducing the carbon dioxide consumption. Because rather than going for individual computing system, because if you go for individual computing system, we need individual facilities to cool the system, run the system, electricity, and all these aspects also indirectly linked to climate change. And if you go for greater clouds based solution, Amazon, Google, or Microsoft, that will also ultimately attempt indirectly the climate change issues. So though it is not meant for reducing the climate impact, it is meant, they are good business models, but they are helping to reduce the climate footprint. And these are the some of the non-technology. If there is only non-technology, we will emit this much of carbon dioxide, trillions tons of carbon dioxide. But with the advanced technology, we can reduce the emissions. So that is some of the projections. And coming to the innovation on the other side, in terms of weather forecasting and modeling, we are using lot of data from satellite, radar, lidar, surface. And we are efficiently optimally using all this diverse type of information from different platforms, heterogeneous information from different platforms. It is almost like petabytes of data is coming at every second. So that is really a data problem, and we have to make use of all this heterogeneous data optimally to produce the weather prediction. Because if you look at the skill of weather prediction 2020, it was almost like a 50% for the one-day accuracy. Now it is reached to 70-80% for one-day advanced prediction. So that much accuracy is being achieved due to the lot of technological innovations happening in the field of telecommunication, satellite technology, radar technology, and then data handling technologies, like more efficient way of handling with all this, like artificial intelligence, data fusion, everything is contributing. Even now the supercomputing power is increased, and data storage capacity is increased, and all this is contributing to the weather prediction problem. And now the quantum computing is another emerging field that also definitely going to help us. So that means we are beneficiaries of almost all type of technology. Actually, the history says that the radar systems are invented to to detect the energy, means enemy targets. So that finally evolved as a remote sensing mechanism to observe the other, because there were during that time there were attenuation happening in the electromagnetic spectrum. So then people started working out of what is the real cause of this attenuation. And then that resulted in deriving different climate related parameters from the atmosphere. So and satellite technology is developed not for climate science. It is developed basically for the communication purposes, because that also we in climate science or weather prediction science, we make use of this satellite and radar technology combined with information technology, telecommunication technology. We are better equipped with producing more accurate weather for the future. So all these technological aspects have been contributing to the climate change issues and the weather prediction issues. I'm not going to discuss much about this because time is almost like 45 minutes. I am exceeding the time allotted, because this is also a challenging problem. Weather prediction model, we have to build this model each and every point on the earth, because we discretize this earth surface into different grid cells and making and solving all these equations, like fundamental 7 equations involving the Newton's laws of motion, mass balance equation, energy equation, thermodynamic equation, continuity equation. All these equations has to be solved at each and every point on the earth surface. So that is basically, these equations are partial differential equations. We have to solve it by different forms, and so that since there is no analytical solution, we have to solve it numerically. So that is why this section is known by numerical weather prediction. So goes, and for that we have to run this model or this equation at each and every grid cell. So grid cell, size of the grid cell is also very much important, because earlier we were running at a resolution of 100-kilometer resolution, because that means in Kerala we will get only 3 grid cells. So now we are able to run 5 kilometers, because in Kerala we can every 5 by 5 kilometer grid cells we can run the model. So that means so much spatial information will be there, and so that for that running that type of model, we need to get a lot of information to initialize these models. So for that we use spectrum, means heterogeneous observations like surface observation, radio sonde, balloon observation, aircraft, then different type of satellite observation, and we will make a final analysis at each and every grid point. So all these heterogeneous observations, we will make use of it, and we will come up with the optimal solution of the true atmospheric state at each and every grid point on the Earth surface. So that this is known by data assimilation. This another field nowadays, ensemble Kalman filter and variational assimilation techniques, and now the artificial intelligence based assimilation techniques also being used by climate scientists for this for finding out this optimum solutions in an efficient or fast way. And because why our forecast really fails is mainly because of 2 factors. One is connected to the errors in the initial conditions. So that means even with satellite also, satellite is not, or satellite or radar, they are not directly measuring the temperature or humidity or wind speed. So we are measuring the basic energy dynamics, or the emittance, or the energy output from, or either in terms of artificial radar, active or passive remote sensing, we are making use of energy. So that energy which is being detected by the sensor is being converted to different physical parameters. So that estimation and derivation also involves a lot of errors. So that will leads to errors in the initial condition. So that is not really errors, they are uncertainties in the estimations. So that means with that uncertainty in the initial conditions, we are running our model, and then error in the model, because all this model at each and every point we have to represent all the physical processes like cloud systems and turbulence, all this, and wind pattern. and building structure, vegetation, everything has to be incorporated. That is what the model, the equation which has to represent the real, it should be a kind of prototype of the atmosphere. That is not possible because we are making a lot of assumptions, because we are depending on a lot of empirical relationships to arrive at physical models. Both we use, so that empirical relationship also has got some kind of uncertainty. So that means these together, the data uncertainty, the model uncertainty, that together is the main source of uncertainty in our forecast model. So this is going to be a big issue, because we have to live with uncertainty, and we have to live with that. And so there are different varieties of big data. That is nothing but the high volume, high velocity, and a variety of the big data is coming. So we need to handle all this data. So that is mainly should be with supercomputing. So we know that there are top 500 list now. India, Pratish was there in as 39. That also changed now. Another CDAC based system is coming at a 68 position. So that means all this problem is, and another innovation we have to make in the field of disaster management, because if you look at Kerala, we are going to face a lot of heavy rain, flooding, landslides, lightning. All this has to be done. And if you look at the disaster paradox also, total disaster is increasing, but the death rate is reducing. That is nothing but better forecasting of this even well in advance. So that is reducing the fatalities. So that means our risk is increasing by due to climate change, because the hazard, the hazard is nothing but different type of hazard. The extreme weather events like floods, cyclones, typhoon, thunderstorms, lightning, all this hazard is going to increase in the future due to climate change. So that is directly linked to this. That means in the future risk is increasing. So this is can be done with the better disaster management plan also. There also technology is going to make a bigger role. Here, if you, for example, the landslide problem is increasing in Kerala. So the wireless sensor based networks and MEMS based accelerometers are widely being used to detect the landslide issues in the Kerala. And so that wireless based data transmission is also helping to find out the displacement in the land, maybe 1 or 2 hours in advance. And if we merge all this information with the weather models and forecasting, we can predict the disasters well in advance. So that means the technology is the solution, and the future there are two aspects like mitigation and adaptation. And the mitigation part, technology based solution has to be attempted at a global as a global issue. When it comes to adaptation problems, like whether in terms of life and life, another part connected to this livelihood issues also is a major issue connected to climate change. So we have to devise different technological solutions to address all these problems, and these are some of the glimpses of what is climate crisis means. And we are really living in an era of climate emergency. We have to come up with solutions. That is our duty. So I think the IEEE Day theme is very apt in that sense. And let us hope that our technological innovations will save the planet. Thank you very much.
Thank you, Dr. Abhilash. So before we conclude, we have a formal vote of thanks, but may I request all of you to just switch on your video. Can we have a photograph? Because we need to pin this for the IEEE Day, right, Kasim sir? Yeah.
Some questions are there in the
chat. We will address that, sir. Just a photograph, and after that.
Sure.
I request all of you to just switch on the video. We have many more people. just, yeah,
To play.
yes. So I'm just taking the, Bijoy, will you be able to take the photograph? You are
can do that.
muted.
Yeah.
Okay, please, please.
Joy. To play.
I think I have
Okay.
not.
It's
Oh,
done.
yeah. Okay.
Okay, good.
Thank you. Thank you.
Yeah.
Over to you, Biju.
Vijay sir may, he has warned me that he might have some internet issues. Are you
Bijoy, that chat questions in the chat box we have to
right?
consider.
We'll take it up, but Vijay sir was supposed to do the moderation and vote of thanks.
Yeah.
Can you hear us,
Vijay?
Vijay sir? Okay.
Yeah.
Okay.
Yes,
Can
yes,
you?
Vijay, I can take over. Yeah.
Okay. Carry on.
Yeah. Sure. Thank you, Dr. Abhilash, for the very informative talk. We have a couple of questions in the chat box. Shall I read out, Dr. Abhilash?
Sure.
Yeah.
Yes. Biju,
So the
please.
first question from Dr. Ravindranathan, which is the most important factor in causing climate change worldwide?
Greenhouse gas emission, that is the main driver. So that is due to many activities. Cannot pinpoint one, but there is a major primary cause.
Biju, there is another question from
Next
Anil.
question.
Anil.
Yeah, I will read out, sir. Yeah,
Yeah.
I will read out. Kasim sir, I will read out.
Yeah, sure.
Dr. Abhilash, how to reduce the CH4 from cattle if they are fed with the seaweeds?
That is actually, really speaking, I am not an expert in both electronics and this field. But what I found is that by replacing the feed with the seaweed, another problem with seaweed is that it is not available in plenty. So that is another issue. So maybe the metabolism related to cattle, they may be the main factor which is determining the CH4 emission. Maybe I don't know much about this. I don't know much about this, but maybe the metabolic activity is the related to that seaweed factor is maybe making that. Sorry for that. Yeah.
Okay, thank you. One question from Ayub Khan. As the mobile background electronic communication, as the mobile communications generation is in progress, how the radiation from each mobile device affect the global warming? Is there any study regarding this fact?
That also I am not well aware, because mobile radiation is not in the thermal spectrum. So I don't know how much it is going to affect the global warming issues.
Yeah, it's as you mentioned, it is it's basically on the mobile communication, the communication part. Okay, thank you. Another question from Dr. Ravindran. What is the contribution of forest fires to climate change and carbon emission?
Yeah, it is forest fires are increasing due to climate change and due to global warming. So indirectly, in terms of emission, it is emitting lot. So it is a kind of feedback mechanism. Global warming is increasing the forest fire events or heat wave events. That forest fire is contributing to a lot of carbon dioxide emission to the atmosphere, and also reducing the carbon sequestration capacity of the forest. So that is a kind of feedback loop, positive feedback loop.
Okay, thank you. I think we have taken all questions in the chat
Can I
box.
ask one question? Yeah, Dr. Abhilash, there is an argument that is made that heating of the earth and cooling of the earth has happened so many times in history, right? So this is, this is something that we cannot avoid. Maybe it is not good for human beings, but this is something that has to happen. How do you think about that? About Earth has frozen before, right? So maybe this is a natural occurrence. What do you think about that argument?
No, there are because that is the only difference is that the time scale at which the natural process and the anthropogenic activity is happening. That is the main difference. So because if you look at the entire evolutionary cycle, because I don't have time to explain the evolutionary link to the climate, because the evolution by natural selection had happened, and also modulated the climate fluctuations might have modulated all these evolutionary cycles. So that means the evolution by natural selection linked to climate change, that is happening over a period of millions of years. The time scale is the main thing here, because the natural changes in terms of changes in the orbital cycles of, that is known as Milankovitch cycle, that takes around 1 lakh years. That is the main driver of this glacial interglacial cycles, that is happening over a period of 1 lakh of years. So in that we don't expect much extinction crisis, because the entire earth may not be freezing, only part of the earth is freezing, but there are evidence that earth were in a snowball type of earth once it was frozen throughout. So that is also witness, earth witness that pattern also. Okay. Here time scale is the main thing. So the present changes, what is happening is unprecedented in almost all activities. Like carbon dioxide concentration is highest in the last 2 million years. So carbon dioxide concentration were very high, maybe more than this, maybe 2 million years back. So that is a natural factor. So that time humans were not there. Human history is only limited to, especially Homo sapiens, only our history is limited to 2 lakhs of years. So we know only within that period. So the changes are inevitable. Even if you connect it to plate tectonics, our whole type of earth process or the climate, what we are experiencing in terms of monsoons or the rain, what we are receiving nowadays, it was not like this maybe 10 or 100 million years back, because 100 million years back our position was with South Africa in the southern hemisphere. So the present climate has also only limited history, like less than 60 million or 6 crores of years. So that means the climate is evolving in tune with the natural processes. So that is happening over a space time scale of millions to lakhs of years. But what we are experiencing nowadays is unprecedented in terms of, and also not with this type of rapid or rate of increase is never witnessed. Earth never witnessed. In there we should understand that whether Earth will remain as such, because Sun has got another 4.5 billion years of lighting of fuel in Sun. So Earth will also remains like this for maybe for another 4.6 billion years. But the question is that whether human will survive or not, or that is the main question. So yeah, it is a very good question, and there is no single answer for that, but it is related to many factors.
Thank you. I hope there is no more questions, and I think we can conclude. So today we have very informative talk on technological innovations to meet climate change by Dr. Abhilash, Director Center for Atmospheric Radar Research. And he started with his talk on various causes for climate change, and later on moved it to the recent technologies to combat the climate change. He talked about the climate change assessment cycle. Then he touched on the carbon budgeting, the climate system, and various aspects of climate change. And then in the second part, he did talk more on to various climate change. How can we use technology to meet this? Basically, he started with and goals, and he touched upon the relevance of sustainable economy and the circular economy, instead of the economy.
I think Biju sir has internet issues, so I'll just take over. So once again, Dr. Abhilash, thank you for taking the time. I have listened to you once in Kochi subsection, and we thought, okay, who better than you to talk about technology and how it affects human beings on IEEE Day. Very important topic to all of us. So on behalf of IEEE Kerala Section, I would like to thank you, and thank you for the audience for staying for question answer session and participation on IEEE Day.